Here we are. Okay. Bismillahirrahmanirrahim. So the first thing that you need to remember is that when you're required to find the integral of 1 over 1 plus x squared, how would you be recalling that it is going to be tan inverse of x? The thing is that look at this x squared. If it was something like this, for example, if it was like this, x over 1 plus x squared, then you can see that, oh yes, 1 plus x squared's derivative is 2x. So if I just write a 2 here and a half here, so this can result into half ln 1 plus x squared. Okay, now there's one more case. Now suppose if it was, instead of 1 over 1 plus x squared, this could also be 1 over 1 minus x squared. Now for this, you can see that you can factorize the denominator here, okay? And this is going to be 1 over, now guess how would you further integrate this 1 over 1 plus x into 1 minus x? Yes, but you have done this. Yes, any idea how to do this? How to go beyond this step now? Yes, hurry up.
Sir, partial fraction.
Yeah, exactly. You will have to write the partial fractions and then you will further like complete this integration. If you come back to this situation here, this is the integral of 1 over 1 plus x squared. This is none of these two situations. We are basically dealing with this integration of tan inverse of x. I mean, this kind of integration that results into tan inverse of x, that is a part of the integration of rational functions. Okay, so now there is only one option left here, that is going to be the tan inverse of x plus c. So if you see that if you have to differentiate tan inverse of x, that is going to be 1 over 1 plus x squared. You have to integrate 1 over 1 plus, let's say there is 4x squared. Okay, so this should be in this form, 1 plus 1 x 1 over 1 plus x squared. So how would you integrate this? You will have to write it as 1 over 1 plus, and you will write it as 2x whole square. So when you have this angle is now 2x, so you need to have 2 over here. So you will have to have this half here. So this integral would be half tan inverse of 2x plus c. Suppose you have to integrate 5 over 1 plus 9x squared dx. Okay, so this has to be, I can write this 5 outside here, and this will be 1 plus 3x whole square. So the derivative of 3x is 3. So I'll write 3 here, I'll write 3 here. So this is going to result as 5 over 3 tan inverse of 3x. Okay, so now there is a hint for you people that, for example, if you have something like this, you have 1 over 1 plus, and this is a square x squared, you can directly write it as 1 over a tan inverse of ax. Now this is for the super kids, the ones who are good at memorizing the things. Otherwise, you can show, definitely you can show all these steps. And like if you directly write from this to this, you will be getting full marks for this, okay? But if you want to write all these steps, this is totally up to you, okay? So when we have to integrate, we have to get the integral as tan inverse of x. So there is this condition that this has to be 1 plus, and here it has to be a whole square. Now suppose you have 1 plus 2x squared. So this will be, look at this, how will you handle this situation? So this is going to be 1 over 1 plus, I will be writing it as under root 2x whole square. And then I have under root 2 over here. I'll have 1 over under root 2 here. So this is going to be 1 over under root 2 tan inverse of. I remember that girl saying that we can't multiply with the variable. So we are not at all going to multiply or divide with the variable over here while adjusting this situation, okay? So this can only be a number. I think that was Aliha who was asking this thing, okay? This is Plasi. So guys, the first situation, the first condition is that there should be 1 plus a whole square over here. Now what if you don't have 1? So that was the first kind of situation that you already have a 1 over here. Now, what if there is no 1? Like this is anything other than 1 here. Now, suppose you have a question like this. You have, let's say 1 over 2 plus x squared. This is 1 over 2 plus x squared. So we can't write this as a tan inverse of x until and unless we have a 1 over here, okay? So how can you have 1 over here? You will have to take 1 common from here. So this will be, I'll be taking 1 common. So, sorry, not 1, I'm sorry, 2 common from the denominators. When I take 2 common from here, let me make it a bit easy for you people. Let me take here 4 instead of 2. Okay, I'll take that to later stage. This is 4. Imagine, why did I change this 2? Anyone? Why did I change 2 with the 4? Hurry up. The recording
Sir,
is
so that you would have.
For what? Yeah,
Sir, so that you could have a 1 in the denominator.
I could have 1 even if there was a 2 over here. Why did I change 2 to the 4?
Sir, perfect square.
Yeah, it's a perfect, exactly right. It is a perfect square. So this is going to be 1 plus x square over 4. And this is your dx over here, okay? So now this will be now 1 over 4, and this is 1 plus x over 2 whole square, okay? So what is the derivative of x over 2? That is 1 over 2. So if I multiply this 1 over 2, I'll divide it by 1 over 2. I'll just write 2 over 1 here. Okay. So this is going to be half into tan inverse of half x plus c. Okay, now there is a package for the smarter ones. You can directly write from this to this. There is no need to show all these steps because there is a rule saying that if you have, again, bacho, this is totally up to you. Like you can use the rules. And the second stage of this where you don't have a 1 here, if you have 1 over a squared plus x squared, you can directly write it as 1 over a without showing any steps, tan inverse of x over a. Okay, this is totally an optional thing. You can show all these steps and go reach this integral. And the smarter ones, the tez bachas, they can directly write from this to this step. Okay, so that is the second stage. In the first stage, we always had have a 1 here, but you have to make a 1 here. Otherwise, this cannot be written as the integral of tan inverse of x. So this term should be 1, okay? And like we have done it here, this should be a 1 here, and this should be a perfect square, like we have written this as x over 2 whole square. So once you have done that, taking common whatever you do, and then you have to satisfy this rule that this numerator should have the derivative of this angle over here, which is x over 2. Okay, so going towards the third situation here. Now, sometimes you have, this is the hardest situation. Like, for example, you have to integrate 1 over, this is, let's say, I'm again taking an easier case here, 4 plus 25 x squared. 4 plus 25x squared dx. Now there is this 4 is disturbing us, okay? So we need to take this 4 out. This is 1 over 4. So this is 1 over 1 plus 25 over 4x squared, okay? Now, we have to do that essential things over here required, like this has to be a square. So this is 1 over 4, and I'll be writing it as 1 plus 5 over 2x squared. Okay, so you see, keep on checking that all these statements are same. There is no difference in their numerical values or their expressions. Okay, so now what is the derivative of 5 over 2x? That is 5 over 2. So this is going to be 2 over 5 over here. So multiplied with its reciprocal. So now this is going to be 1 over 10. And this is tan inverse of 5 over 2x. So guys, I have explained the 3 possible situations to you. And now this is up to you. You start from the exercise 1D. Okay, start practicing the questions from 1D.